Greetings. We are table number 23 and we're recording this on the 14th of September 2018. The main goal of this lab is to determine the internal resistance of the MyDAQ as a signal generator. To do so, we are going to be applying the load line measurements from part 1, but this time we are going to use the MyDAQ as a signal generator, and we are going to be using a potentiometer as a variable resistor. Using a potentiometer, we can also determine, or we can also read the maximum output current if we set the potentiometer to the lowest resistance it has. If we vary the resistance of the potentiometer, also it's gonna vary the voltage that is gonna be read in the oscilloscope, as you can see in the screen. The results we got are the following.
So here we have the data obtained. The potentiometer has a minimum resistance of 5 ohms and the maximum is 10 ohms. So the voltage for the minimum is 4 millivolts and for the maximum is 10 volts. And the current, as we said before, for the minimum is 2.33 milliamperes, for the maximum is approximately 1 volt. So here we have the sketches. The first one with a potentiometer and the second one with a LED diode.
In order to see that graph that was just explained, we're gonna replace the potentiometer with a LED diode, and we're gonna see that indeed the graph obtained in the oscilloscope is the showed. So to answer the questions established in part 2, what happens if we short? If we short, we're gonna be reading the voltage that is sent by the MyDAQ after the internal resistance, which we determine to be of approximately 2K, since the maximum output current is 2 milliamps and the maximum output voltage that we got is of approximately 4.9 volts. And what is too much current? Well, since we are using a LED diode, the maximum or too much current will be more than 20 milliamps. So of course the MyDAQ is gonna be sending less than that, but enough to turn it on, as you can see.